Hello, this is Mr. Collier, and today we are identifying outliers in sets of data and comparing box plots. Okay, so let's look at how to identify outliers first of all. So these formulas right here, let's check it out. Maybe another way to rewrite it is, well, let's just look at it in general. If you have a box plot, here's Q3 and Q1. Now an outlier is something that's really a lot larger than the rest of the data or a lot smaller. So an outlier might be over here somewhere. Okay, so this is a lot bigger than the rest of them. But we needed some sort of cutoff place. Like, is this an outlier? Is this an outlier? Where do we determine if it's an outlier or not? So one way that someone developed is to create an upper and lower bound for outliers, and the formula is Q1 minus 1.5 IQR for the lower bound for outlier, and Q3 plus 1.5 IQR for the upper one. Okay, so that's the method we're going to be using in a second. And then we're going to be comparing with the box plots, okay? This is car travel time, traveling by car, or bus travel time. So let's get the data, determine if there's any outliers, and let's create the box plots. So I'm going to do that in Desmos. I've already copied the data into Desmos. Then to get the box plots, you can simply type boxplot bracket A, and a box plot shows up. You can adjust the height and stuff. I'm just going to zoom in, and then I'm going to do box plot B, and I need that to move up a bit. That's the width of the box plot, so offset, yes, so let's do that. Actually, it looks like there are some outliers, so it looks like Desmos does use the formula to create outliers. So it looks like there's two outliers, but we're going to show that in a second. So you can let's leave it like that. So we can see the two outliers, but we're going to use the formula in a second. You can also just click on down here. There's a bunch of functions, so you can read them yourself. We can click on this one here, stats A, and we get the quartiles and the mean and the median. We can click on stats B, and we get all the quartiles and the median and stuff as well. These are what you need for creating the box plots. Okay, so yeah, let's actually do a screenshot of this and bring it over here, and we'll use that in a second to compare box plots. But let's determine if there's any outliers first of all. So we have looks like the outliers are here, so let's use the outlier formula here. The lower bound, I guess, for lack of a better term, is Q1 minus 1.5 times IQR, and IQR is Q3 minus Q1, and we have that in this little table here. We have 24 minus 14 equals 10. So the IQR is 10, Q1 is like 14, so you can do 14 times 1.5 times 10. That's actually 14 minus 15, so that's negative 1. There are no negative numbers in this box plot. The minimum is 12, so there's no small outliers. Okay, so if you go to the upper bound for the outliers, we do Q3 plus 1.5 times IQR. Q3 is 24. Okay, 24 plus 1.5 times 10. That is 24 plus 15 is 39. Okay. Now do I have these two mixed up? I do. The red one is the one with the outliers. That is box plot B. So you can see the black one here, there's no outliers. And you can see there's no data values bigger than 39. This is exactly 39. So it is not an outlier. It has to be bigger than 39. And your lower bound for the outliers is negative 1, which is way over there. So if you look at the box plot, black box plot, there's no outliers. But it looks like there will be outliers for the other one. So actually I should probably label these more properly. The black one is the actually car, and the red one is bus. So there are some outliers for the bus data. So let's check out the upper bound for the bus data. The IQR for it is, let's check out the data, 17 minus 14. So we have a very small IQR. I guess that's why we have some outliers. So the upper bound is Q3 is 17. 17 plus 1.5 times 3. That's 4.5. That's 21.5. So anything bigger than 21.5, which is right there, that's 21.5. Anything bigger than that is an outlier. That's why these two are outliers. Okay. So that's how you determine if there's an outlier. Let me erase these things here so I can annotate the box plot a bit. Okay, so yeah, we should label them. Should label the axes down here. This is time in minutes. Time in minutes. And let me erase this over here. And I guess you could say Jeff's travel time to work or school. Okay, now once you have a box plot, you can compare them. Okay, here's a nice place to compare right here. This is the median for the bus, and this is Q1 for the car. Okay, so you can compare those and just don't talk about Q1 and median, just use actual percentages. Okay, so you can say 50% of the time a bus takes less than whatever that number is, looks like 14, less than 14 minutes. And 25% of the time a car takes less than 14 minutes. Okay, so we're comparing those values directly, so it looks like a bus is a much better option because we want a lower time, right? So 50% of the time or less than 14 minutes. But you could also say 75% of the time a car takes more than 40 minutes. So it looks like the bus is the better option. You can also compare things like maybe the medians. Okay, you can also say right here like 50% of the time car takes more than 17 minutes. Okay. You can talk about this one, Q3 for the car. So that means 25%. Remember, each section of the box plot is 25%. So 25% of the time a car takes more than 24 minutes. But that only happened once with the bus. Okay, so it looks again like bus is a better option. You can also compare directly the IQRs. We calculated the IQRs. The IQR of this was car is 10, and the IQR of bus is 3. Okay, so since the IQR of bus times is 3, and for the car, or by car, it's 10, the bus is more reliable or consistent. Let's say reliable. Okay, and you can also compare the range too. The range for the car is much bigger than the range for the bus. The range is maximum minus minimum. Okay, you can also do things like you can also calculate things like in this function app of like, let's see, standard deviation P for population standard deviation A, and then you can do the same thing for data set B. Oops, that's not what I wanted. Let's go back to here, function, statistics, standard deviation P for population standard deviation. So you can compare them, and you can see for data set A, which is the car, this means it's less consistent than by bus. Okay? Standard deviation is a measure of how far all the data values are away from the mean. So this means that the car is more consistent. Okay, you can also compare the means. You can go to function, and where's the mean? Mean is right there. Do mean A, and you can do function stats. Okay, mean of the B. I did not mean to click that. I meant to click the mean. Mean B is 15.9, so that means on average it takes 15.9 minutes by car, and by bus, sorry, I think this is the other way around. Status set B was bus. Bus is 15.9 minutes. On average, takes 19.8 minutes by car. So everything points to the bus being the more reliable option and the bus being quicker on average.